So, hello, good to be here again. I'm Robin. I work for a company Encore, test automation consultant, and getting my hand dirty with test automation. So, last year I talked already about some API libraries, API testing libraries I've wrote. There were some questions afterwards, and it kind of made me go back and think, okay, it would be good for this year when the proposals were asked for to maybe see what are the options and yeah, just expand on the pretty technical talk from last year. So agenda for today, I'm actually going to go back to the basics first. Just build up what are the key elements in API testing that we'll be dealing with. I'll look at the libraries, the ones that I call them established libraries. They're around for like many years, so they're in a mature state. Well, the clock is not running, by the way. If someone kind of gives me, otherwise you'll be here for a very long time. So Renee said I had extra time, but that's probably not what they meant. Thank you. Then I'll be revisiting the libraries I wrote, OpenAPIDriver, OpenApiLibcore. Also a word on RoboSwag, also last year or a bit before. And I'll have, depending on the time left, some words on the Python side of things. Why you would want to do that, maybe. So, API, Application Programming Interface. Did we know this? Yeah, I think so, right? What's important to realize, it's about two software components, two machines talking to each other. And to do that, we have definitions and protocols. And the protocols thing we'll see in a bit. Now, we have a number of types that we can see. Like, if you have something where you talk to a database, you probably have this database plugin, and that's an API, because that plugin is software that talks to other software, the database. The same for your operation system. Win32 DLL, that's an API, because it's a thing that you can talk to. It's software that talks to other software. Remote APIs, and then we have web. So today I'm going to be focusing on web. And there's two main things here. We have a client-server architecture, which basically means there's a server somewhere that's just waiting for you as a client to ask it something. So the client starts the process of communication. It uses HTTP. Who here has not heard of HTTP? No one? Yes, of course. It's the internet, basically. So, web. Now, there's a few common types if you Google on web APIs. So, what are we talking about? You see REST, SOAP, RPC. I think that's the main ones being mentioned, found. I'll be going into REST. Indeed, I won't be going into SOAP, but a lot of things that are applicable to REST are applicable to SOAP. Just the data formats are a bit different. RPC, also interesting, but the model behind it is different. Not as much used, I think, by most of us. But it's also there. Just know it's also web, it's also HTTP, just you do things a bit different. So HTTP, the foundation of data communication for the web. It's a request response protocol, the protocol in the client-server model. So client does a request, server does a response. We have URLs. You might also see URI. Technical differences between them. For most, if you have to deal with them, see the term, they're probably the same to you. The request methods, get, post, put, all these, are from the HTTP protocol. They're not REST or having to do with JSON or anything. They're at a lower level, just HTTP. You can easily see that also if you open your browser, go to robotframework.org, see in your developer console what happens, and you'll see just a get on the URL. And you can see the request and response. Pure HTTP. Same for the status code. It's also just that basic level what we're talking about. Now, the next one I won't be going into detail about. I do want to mention them, but we will see them again. Idempotent, stateless, cacheable, layered. Now we get to REST. And I want to talk about this a bit, because I think REST is much misunderstood. It's an architectural style that has defined some rules for creating web services. It does not state anything here about being a standard or anything. It is not. It's a style. You can be very free in what you do with it, how you interpret this. You can't say, oh, we do REST, so it is like this. It doesn't work like that. So if someone says, well, we do REST, so you should know how it works, that's not what REST says. So if you want to know more about REST, Roy Thomas Fielding put out a paper, does a lot of talks on it. So if you want to research it, Google this man. But what he says, RESTful APIs adhere to 6 architectural constraints. So we're talking architecture. How do you design this API of yours? And what boundaries are there that rules are there that you should stick to? And the main one I want to focus on here a bit is uniform interfaces. It's not a standard. It doesn't say how your interfaces should look, but they should be uniform. They should be logical, predictable. So if you find an API somewhere, have a team that says we're doing a REST API, and there's an API endpoint about users, and then there's one talking about clients, and then the users are the clients, you should challenge that team and say, well, this is not uniform, this is not logical. You say we do REST. Maybe we should do better, be more consistent, because that's what REST is all about. Now, the next set of rules, boundary, constraints, client server, stateless, cacheable, layered, HTTP. If you stick to the HTTP protocol, these are checked. You cannot go out of them. So that's quite easy. And then, well, of course, REST APIs is done. It also has a bit about code on demand. And that's an optional one. I don't see it very much in practice in APIs that I've been dealing with. It basically says some things about how that you're allowed to have a thing where you get this client that requests something and then you get code back that the client can execute. Now, from security perspectives and all these things, a lot of people don't really want you to do this because you're calling this server that you may or may not know, and it gives you some code that you've never seen before, and you go, yeah, I'll run this. Could be good, could be bad. On APIs, I don't see it much. Browsers does do this stuff with JavaScript and all that, but they're sandboxed and very secured and all these things. And now if you just have an API endpoint and you do your API test tools, I rarely see this or never seen this. So moving on to OpenAPI and Swagger. This is something from their website. If you Google the OpenAPI specification tree, and slides should have little amounts of words. So I'll just do the TLDR, which I just copied from last year. We have this specification, the OpenAPI specification, and this is a standard. REST was no standard, but the OpenAPI specification is. It tells you what you can do, how your how your API should look, what the structure should look, what words, keywords you can use, allowed to use, what sections must be there, how they must look, all these things to make it a really structured thing. And then we have the Swagger part, which are the tools to work with an OpenAPI specification document. So OpenAPI defines a lot of things, and there we see this REST OpenAPI thing happening, because REST must be uniform. You should do that. And the OpenAPI specification is like, it should be look like this. So if you make this REST API and you get your OpenAPI specification in place and really do that well, you are a uniform interface. So now you know the different terms, what you can expect if a team says, well, we do OpenAPI, we do REST, or maybe not. That's a bit of the basis. Now, going from this basis, we're gonna look at the libraries we have available in our robots framework space. So the RequestsLibrary has been around for quite a while, downloaded quite a high amount a month. So I would like to ask, like, who here has worked with RequestsLibrary? I'm gonna step forward. See, well, that could actually be well over half the crowd. So doesn't surprise me that much. It wraps the Python request library. We'll get back to that later. So we have some really handy features. Session support. You can create sessions, put authentication on sessions. Very useful. Some keywords that deal with file uploads. And from the workshop I did on this topic 2 days back, once you get into files, file handling, file uploads with API testing, I think some in the workshop got it working. My example, I did not yet get it working, so it's a bit more difficult than just doing get and post on JSON stuff. but there are special keywords to help you with this. Implicit resource status validation. This is kind of nice because you can have this get keyword or post keyword and you can execute it. And if the response is not an OK response, some 200 code or 300, it will just fail the keyword unless you explicitly state, I expect some error code. And this is nice because you can't have a script running that does some operation, a post, that actually fails. Then you expect to do the next thing, and then that fails because the previous one, the keyword that did not fail, was actually not doing what you expected. So I like that part of the library that safeguards your keywords like that. And it's good to realize it can work with any content type. In all these things about the REST thing, about OpenAPI specification, it never really said you must use JSON. They offer room to use other formats, like XML. A lot of today is JSON. JSON is lightweight, compatible with browsers. Browsers want JSON because they can convert it into their internal web page models directly, saves them time. But there's no restriction here in RequestsLibrary on this content type. Now, I have some very simple code snippets to just highlight or show the difference between the libraries. They all do the same thing, but you kind of get a glimpse on, okay, here's the differences. So we get on a URL, with on a host, with an author's endpoint, we get a response. That's a list. Now we need to, that response, we need to do a JSON call thing that's inline Python there. And then we have a list, and then we get the ID by getting the first in the list and then getting its ID. And then we can do another get response and check that the name in that response, JSON, is a string. That's a bit how it would look like. So RESTinstance is also been around for quite a while. And I think it's an interesting library. I don't think it's used nearly as much as RequestsLibrary, but I think there's many people who could actually benefit from it. So it has automatic generation of JSON schemas for requests and responses. It has JSON schema validation, and it's more focused on property validation instead of value validation. The idea that's like, if I get some user, I expect there to be a name, and I expect that to be a string, or maybe an age that I expect to be an int or a float. The exact value may not be that interesting. It could be anything. I just want to know if the type is correct, because others using the API will use that to, for example, do a calculation. And then if I want to add something to an age, it must be an age or float, another string. So you kind of want to safeguard that part of your API and not that user X is 5 years old or something like that. Just a number. I need to be sure about that. So there's special keywords for that also in this library, focusing on that data types thing. Here you see that the library does this thing where you can just give the host to your instance and then don't have to write it anymore in your calls. You see that that does a get, and it doesn't capture any response. The library on the background stores that information, and you get access to that by this output keyword that you can use, or response keyword. And then you can say, okay, from the output, get the first element of that, we know it's a list, and get its ID, and assign that to a variable. And then do the get, and then say, in the response, part of what we just did, for the status that's in there, check that it's an integer and its value is 200. Response body name, I want that to be a string. Not interested in the entire name or anything, the specific name that will break when you change your test data, but just it must be a string. So, libcore, I wrote it, so small disclaimer there, I'm a bit based. The idea here was to take that OpenAPI specification, it's a very structured thing, standard, and expand on that. Use the information that's there, that you can use to show a Swagger UI and all these things, to make keywords that are a bit smart, can do heavy lifting for you, saving you time on writing more keywords to do multiple steps. Also because your specification tells you like, okay, this thing, I need a name, it must be a string, it must be not more than this many characters. I need, well, all these values are defined, the types are defined, restrictions are defined. And well, if we're not too interested in very specific data, values, let's generate them. We have this faker library, it's great. You can give it a localization and I ask for a name and you get like a Finnish name every time you run this. So you won't be repeating hard-coded names, you get just new ones every time. But they are compliant with what your specification says they must be. Now, if we're doing REST, things should be logical. We have patterns. If I have users and points, I expect to be able to get them and get a list of them. It's a collection of the same thing, so it should be a list. If I post one there, a new one should be created. And then if I have an idea, a resource, we're talking about resources here, I should be able to get them. And then you can do interesting things. Delete a specific user. Well, if I want to do that, that might not be handy in a set of data that I do not control. So maybe it's wise to first create a new one. And if it's REST API, that should be logical, consistent, and all these things. I can just say, oh, you want to delete a user with some ID. Let me post one, and I know how to do that because the specification tells me. So I do that, and then we go to proceed and delete that user and let you know what happened. Now there's in the library support for mapping between resources. The workshop participants got to see what those resources, how that works. I need to have that ID of that thing before I can post this new thing. And there's stuff for that. So the same example we did in libcore would be, okay, get me a valid URL for this endpoint. And then, okay, do a post. Now, you're like, but what was the author ID then? Well, I don't know, I don't particularly care either. I didn't go to a list and find like a user in that list and get its ID. I just asked like, get me a valid link to a resource, a use resource. And if you would run this, you would see that that new user was posted. It's just create it, get its ID, give it back, get a new URL for that user endpoint. And then we can do the validations again, which looks similar to RequestsLibrary. OpenAPIDriver just is the data-driven version of this. Do a contract, go. Contract testing, you don't have access to your actual keyword calls. Copy paste this basically and run it. You'll have, depending on your API, many or a few, could be hundreds of tests being run. Now I want to mention RoboSwag. They're in alpha status yet. The guys doing this, Mateusz, Bartolomeus, are quite busy with other tools, Tidy, so they're very valuable work doing for the community. But this generates Python code classes for endpoints and models, and also generates JSON schemes. That's something I find very interesting, because we have on the left side like a model, a Python model that you can just instantiate, and it will have all the properties that are needed. And then on the right, we have the class for the endpoints. And it has all these methods to do your requests on the endpoints that will be there. All endpoints that are there. So we can go and, well, maybe go a bit further with this class and make it a robot framework library and put the decorators for keywords in there. And then you would just have keywords out of the box that you can call. And then you could just go and in the keyword set your preferred name, because the generated one are from specs, and specs kind of need to generate something unique, so that might not be what you want. But you can then just go and tweak and not write all this code yourself. And I think that's a very interesting concept. So now I was allowed to run out of time a bit. I am doing that right now. So just short note on the Python side of things. Requests library in Python, de facto standard for HTTP in Python. Really, I mean, I think they're like it was something like 10 million downloads a week. That's everyone uses this. There's a lot of documentation. It's really good documentation. It's very complete. Lots of examples. Also lots of guides on how to do things. All our robot framework libraries use this, use requests. So just studying it, look up the response object on the documentation, because that's what you're getting when you use the robot framework libraries. See what methods are then. If you kind of understand that, you know what you can do on your robots framework side. You'll learn that if you get a response, you can get the original request out of it with everything in it. And that can help you, I think. Now, why would you go and make your own libraries? For me, number of times I got in a situation where the libraries that are there did not fit my need. I needed to do some exotic things that you typically don't want to be doing, basically, but still have to, because you're having to deal with an API and interface that's just so special and different that you don't have an option other than go to Python, do the special things, dealing with boundaries in your headers, dealing with an API that requires an XML format, within it an SQL statement. Then you need formatted text, raw text, and all these things, and I would not recommend trying that in Robot Framework. But the option is there for you to use if you want to. So, oh, not this one, this one. That was it for me. Did I question time and?
Well, a bit, and we ran over time, so unfortunately the questions need to be asked at the speakers corner. Give a big hand to Robin. Excellent talk.